HVAC 360 is brought to you today by the Lazy Days Company, who are proud to present their new award-winning product, the Secondary Desktop. What's that, you ask? Well, I bet you're the type of person that has a desk that looks like a bomb went off. Don't you lie to me. And then all of a sudden, before you know it, an important client shows up at your door. Never fear embarrassment again with the Secondary Desktop and its compound, spring-loaded hinges that allows you to move the pristine new desktop surface into place, covering that unsightly mess in seconds. But what if it doesn't match your current desk, you ask? Don't worry, our inventory comes in all those architectural colors. Order yours now. Hey, welcome back. Matt Nelson here, your host for HVAC 360, helping give you the best and the brightest in the field of HVAC. We do that by sharing information, specific lessons learned in the field, or talking with industry experts. And if all this leaves you hungry for more, you can sign up for my weekly newsletter or subscribe to my new YouTube channel. All right, so what's up for this week? This week, we're going to be talking with Eddie Rodriguez, the Strategic Marketing Manager, and Frank Ford, the Director of Product Management for Turbocor Compressors. They're a Danfoss company. So specifically, what are the Turbocor compressors? Well, if you've ever played with permanent magnets and you kind of flip the positive and or you try to put the positive and positive side together and you get that resistance and they don't let each other touch, well, it's the same kind of principle that they use for magnetic bearings, and that's all what the Turbocor is about. But enough of this description. Let's just cut to the tape and hear from Eddie and Frank. All right, today we're talking with Eddie Rodriguez, who is the Strategic Marketing Manager, and Frank Ford, who is the Director of Product Management for Danfoss, specifically the Turbocor product. How are you doing today, guys?
We're doing fine. Great.
So I guess today we're going to be talking about the Turbocor compressor. No surprise there. What are some of the standard compressor technologies, if we take a larger look at what's out there that you directly compete with? What is out there?
Okay. Well, I'll take that question. So our primary competitors are typically your traditional oiled screw and centrifugal compressors. Both of those compressors require oil for lubrication, specifically the bearings. Because oil is required to lubricate the metal-to-metal contact between the bearings and the motor shaft. And in addition, a complete oil management system is required within the chiller system to ensure that oil is sent back to the compressor. But in recent years, we've been seeing other OEMs and other compressor manufacturers that have been offering similar technology to us, which for us is we offer a complete line of oil-free compressors. Specifically using magnetic bearing technology. So we have seen other competitors, other OEMs offering similar technology, such as using magnetic bearing technology, but also other oil-free technologies such as ceramic bearings or gas bearing type of compressors.
So specifically, how does a Turbocor operate, and what are some of the benefits that you have?
Okay, yeah, so let's kind of take a step back in looking at traditional compressors such as screws. And those types of compressors require a metal roller bearing, and that metal roller bearing requires oil for lubrication between the metal surfaces that come into contact with each other. And those roller bearings are used to support the rotational and linear movement of the motor shaft. On the other hand, Turbocor compressors offer a different methodology to support the motor shaft movement. So instead, we use oil-free magnetic bearings. And those magnetic bearings, what they do is they create a magnetic field between the bearings and the shaft. And by doing so, this magnetic field allows the shaft to levitate and spin in a pocket of air. And by doing that, we essentially eliminate the need for lubrication because there's no longer any metal-to-metal contact between the motor shaft and the bearings. So the benefits that you as a customer would get by using this technology is that first of all, it eliminates oil from the chiller system. And the end result with that is that it provides high performance, improved efficiency compared to traditional technology. because really oil, in terms of applying it on a chiller system, it doesn't really do you any good. And in fact, it inhibits efficiency, inhibits performance. So you remove the oil from the equation, what you get is better efficiency and better long-term performance over the life of the compressor. And then the other benefit you get is that taking out the oil management system significantly reduces your maintenance tasks. So all the traditional maintenance tasks associated with oil, such as changing the oil or changing the oil filter, taking an oil analysis on a weekly basis, that stuff is gone. You no longer have to do that, and the end result is significantly reduced maintenance tasks.
Now, isn't it true that you're also sound actually comes into play a lot because it's not metal against metal grinding. It's a lot quieter.
That is very, very true. So anyone who has sat next to a screw compressor knows that that type of compressor technology emits a very distinct and unforgettable sound experience. The primary cause of that is, as much you said, is that metal-to-metal contact gives a very unpleasant noise experience. But with our technology, since we essentially eliminate that metal-to-metal contact, the end result is a much quieter operation, and the end result would be, of course, a lot less customer complaints because of noise coming from the chiller.
Right, and that kind of indicative of kind of the applications or the areas that you'd be thinking about using the Turbocor compressor in. So now the Turbocor compressor has been around for a while. You kind of alluded to that. Other people are starting to use the magnetic bearing technology. So specifically to the Turbocor, what are some of the steps that you've had in its evolution? And then top it off with what's new with the latest generation, because at the HR Expo, that was one of the things.
Sure. Yeah, this is Frank. I'll take that question. So we have gone through a lot of changes over the years, and even our fundamental business has changed. When Turbocor first started out, we had a hard time convincing people, that our product even worked. Never heard of an oil-free or magnetic bearing centrifugal compressor before, but today it's mainstream. It's widely accepted, and we were the first. So there was a time though, whenever we were going around telling everybody about these benefits, like you mentioned, the low sound, but none of the major players in the industry were willing to take that risk. It was tough when we first started, and we were just trying to get some compressors out. So we actually started in the retrofit market. So we were trying to sell to contractors who would do retrofits on just the compressor on an existing chiller. So they would end up taking off an oiled compressor and replacing it with a Turbocor, and found all kinds of issues by doing that, removing oil and how sensitive that was. But overall, it was a pretty successful start. So when we started to get a little bit more attention, we had a few customers sign on that really were pioneers at the time, doing oil-free chillers, like customers McQuay and Multistack, Klima Veneta, and of course Smart. So the OEM business had started growing and had a hard time to manage all of those one-off contractors doing the retrofits. So we focused the business to centralize that retrofit to just a few OEMs that specialized in it. And we then turned our attention to new chiller builds and compressors for new chillers, so that we could develop a more reliable quality product that the market required. And we got a lot of help whenever Danfoss, that was another change that we had. Danfoss purchased Turbocor, the whole company, in 2013. And Danfoss is a great company in terms of processes, and being part of a larger company gave us access to more resources and support. So lots of changes in our business. And like you mentioned, our product has changed a lot over time too. So originally we started only focusing on water-cooled chiller applications. So then we have expanded our portfolio to include compressors for air-cooled chillers. We actually now offer a high-lift compressor, which meets the entire range of air-cooled chillers and is even capable of doing some heat pump applications. So our new compressor designs, what's really helped us in terms of our innovation is that we've invested a lot in technology. And so before we ever cut metal, we'll end up doing a design digitally first. So we can do all of the modeling and see what the performance is going to look like before we ever start to make a compressor. So that's really helped us in terms of our speed. And We look at other trends, so big trends. Lots of changes going on in the industry right now as far as refrigerants. It used to be very simple. 134A was accepted broadly, and now there's changes around the world for what refrigerants are going to be the long-term solution. And then there's a trend towards electrification of heating that's causing us to look at our portfolio, and another push into data. So using data to make better decisions, which is something that we're looking at for our controls. So continuous changes.
So now, I mean, as far as the, using the electrification of heating, can you tell me a little bit more about that?
Sure. Yeah, it's using refrigerant systems to deliver heating solutions. So water-to-water heat pumps, and then air-to-water heat pumps. So our portfolio of compressors, like I mentioned, the high lift compressor, which we had on display at AHR this year, is one of our newest compressors. It's capable of operating at a pressure ratio of 6.2. So, which is very good for water-to-water heat pump applications, and also good for some air-to-water heat pumps as well.
Now, I mean, as far as the Turbocor goes, what kind of size range? I mean, when I think of heat pump, I kind of get stuck into the smaller smaller product range, but typically that's not where you see the Turbocor being applied. What sort of product range do you see out there?
Right. We have a very broad product portfolio. So that's one of the advantages that we have within Turbocor. So our product, the smallest size is around 65 tons, and then our largest size is actually 450 tons. So, and we have incremental compressors in that range. So the high lift compressor that I was mentioning has a capacity of about 100 tons if you're talking about typical cooling capacity, and a little over that if you're talking about heating capacity. So the heat pumps do typically run down towards the smaller end of our portfolio.
Now, I guess you talk about the refrigerants a little bit. I mean, obviously, some of the new refrigerants, it's not necessarily any issue with some of the more advanced refrigerants coming out.
Right. The refrigerant situation, it's different around the world where you're talking about. So in Europe, we've seen a big trend. We released the first compressor for HFO 1234ZE back in 2013. We call it our TG line of compressors. And we've seen a big shift in Europe towards the TG portfolio that we have now. And this year, we actually released the first compressor, our 490, TG 490 compressor, which is the first compressor for use with R515B. It's a new refrigerant from Honeywell.
So what do you think engineers really don't understand about the technology?
Okay, this is Eddie. I can take that question. So I think for the most part, most customers are aware of the benefits of oil-free compressor technology with regards to the efficiency improvement that you get. You eliminate the oil from the system, so you essentially eliminate a fluid that actually inhibits heat transfer. So you get an immediate gain out of that. But I think a lot of customers are not aware of the long-term benefits. Specifically, what I'm saying is that the efficiencies you get out of taking oil from the system is not only valid on day one, but it's also valid 20 years from now. So the performance you get when we ship the compressor brand new is essentially going to be the same performance you get 20 years from now because of the fact that there's no oil in the system. And several independent studies from ASHRAE has confirmed that it is very common for service technicians to essentially overcharge oil in the system. And whenever you do that, you're essentially going to be robbing performance from the chiller. The other issue to consider is that our compressors do not incur any kind of mechanical degradation over the life of the compressor. You'll find that your traditional screw compressors, it's very common to see those compressors suffer a significant mechanical wear after extended periods of operation. In fact, several OEMs who manufacture screw compressors offer renewal programs to overhaul the screw compressors in order to alleviate that issue. They'll rebuild the compressor with the parts that come into contact with each other in order to allow you to get the performance that you got when the compressor was brand new.
So what's sort of like the life expectancy difference that if you talk about the screw versus what you'd get with a Turbocor?
Yeah. So with regards to our compressors, you can expect a 20-year lifespan with our technology. There's no reason why you can't achieve that with the recommended maintenance procedures. The difference is we see the benefit with our technology is that a lot of the maintenance tasks that you would commonly see on an oil compressor, such as changing the oil filter, monitoring oil in the system, those tasks are no longer required on our technology.
So I guess what kind of I mean, as far as the percentages go, I mean, what sort of energy savings can you get going away from a oil based to a magnetic bearing?
Yeah. So the area that you'll see significant benefits in terms of performance is going to be at part load operation. So if we benchmark our compressor against, let's say, a baseline traditional fixed speed screw compressor, you can see efficiencies improvements of as high as 30 to 40%. Because all of our compressors, they're not only oil-free technology, but they also come standard with variable speed drives. So in other words, it can adjust the power consumption, especially at low load conditions when capacity is not required during those situations. Now, when you compare it to, say, a traditional screw with a variable speed drive, you'll still see some significant performance improvements, typically in the 5 to 10% range, and that's because, again, even though they're both compressor technologies are still using variable speed drives, the fact that our compressors do not have oil offers significant performance improvements in terms of heat transfer.
Okay, excellent. So now, I guess, do you have any lessons learned that you've, from applying the Turbocor compressors over the years? Any designer tips that they should keep in mind?
There are some differences whenever you're talking about designing with a Turbocor compressor. One difference is that you can have a much lower superheat because we don't have oil in the compressor. You don't have to worry about liquid return that could flush out anything. But for the most part, there are some other differences. And just if you're considering having multiple compressors, the majority of OEMs use multiple compressors on their chillers. So 2, 3, 4 compressors on a single chiller, Turbocor compressor on a single chiller, and up to even we've seen 12. That's one of the largest systems that we've seen. And when you have a centrifugal compressor and you're starting up multiple centrifugals at a time, they need to be able to generate enough pressure so that they can start up. So we have check valves as part of the system, and then staging valves. So what a staging valve does is it allows a starting compressor to be able to generate enough pressure to then overcome the check valve of the pressure for the existing the compressors that are currently running. So that's one of the unique things that I think it would be different with a Turbocor based system versus a screw or other type of system.
Now, when somebody's selecting a Turbocor, is it specific manufacturers, or is it something that they can mix and match or specify that a certain manufacturer use Turbocor?
Well, whenever somebody's trying to use Turbocor, we have a set of OEMs that we work with, right? So Turbocor is a technology, and an OEM has to build around their chiller, around the technology. So we work with a limited number of OEMs. Those are all listed on our websites, the OEMs that currently offer Turbocor products. And so if they were specifying a Turbocor based chiller, they can identify, which OEM they would want to work with.
So, as far as the applications go, Again, it's quiet, so it might be, as far as like performing arts, things like that. Are there better applications and maybe applications that are not so good?
There are a lot of potential applications. So we have our products installed, in, like you mentioned, performing arts theaters. So stadiums, they're in metro stations. Metro stations is an interesting one because a lot of times the metro stations are existing structures. So the space is limited. They don't want to use space for a mechanical room. So our technology, being a very small, compact, lightweight compressor, allows to have a small system that they can then bring into the existing space without occupying any more, square footage than they have to. Hospitals is another one. Schools is a really good one because of low sound. Hotels, and of course, office and retail spaces. So, another place would be applications related to process cooling. Data centers is a very large market right now. Lots of our compressors are being used in chillers for data center. But then there's some interesting stuff too, like indoor agriculture, food processing, manufacturing process for plastics or other types of materials. And another really interesting one is on cruise ships. So we actually do have some Turbocor compressors installed on water-cooled chillers located on cruise ships.
Wow. Now, is like you mentioned, there are multiple Turbocor compressors typically on any specific piece of equipment, whether it be a chiller. What sort of redundancy does that allow?
That is a very good point. And, a lot of our OEMs have been very successful because let's say they're bidding on a job and the job requires to have a redundant chiller. So what our OEMs have been able to do is say, well, you can actually save money because you don't need to have an additional chiller for redundancy. We can provide you redundancy by having multiple compressors on the same chiller. So therefore, if there is an issue with one particular compressor, then you have the other compressors which can still deliver not necessarily the full load, but can deliver the majority of the load or the cooling capacity that would be required. So it helps some in certain situations to be able to save without having to spend money to buy an additional chiller and just have the redundancy as part of the compressor.
So now I have to ask, because this is one of the things that we have this magnetic bearing, which is it's not they're not permanent magnets per se, but I mean they're you have electrification. It's basically kind of because that you have power that the magnetic bearings work, correct?
Right. Yeah.
So now, obviously, take away the power, whether it's a power blip or an extended loss of power. What happens? How do the compressors handle that sort of situation?
Yeah, with the compressor, so we do need power in order to levitate the shaft, right? But what happens if you have a very brief loss of power, and we're talking just a few milliseconds, or if you have a voltage sag of a couple seconds, then the compressor can breeze through that, no problem. It just keeps going. But if it sees a voltage sag that lasts more than just a few seconds or a total loss of power, it will go into a state that we call generator mode. So generator mode is when the stator actually becomes a generator. So it creates sufficient power for the compressor to be able to continue operating so that it can then bring the shaft and start reducing the speed and bring it to a safe stop. So that's the protection that's inherent to every Turbocor compressor. And, another problem that people have is if the compressor does shut down, well, then they start to lose water temperature. And what we have as well is a function in the compressor that we call a fast restart. So once power is restored, we'll be able to start up quickly, and within 30 seconds, the compressor is up and running again, so that the chiller can continue to maintain the water temperature.
So I guess one other thing that I was kind of thinking about is that how since it's just spinning at a high speed, it's levitating there. How susceptible is it to shock? From running into something to even like an earthquake.
Yeah, that's a good one too. So our OEMs have obtained seismic certification on chillers using our compressors. So there are specific standards that they have to go through in order to say that it meets the seismic qualification. And so they have taken our compressor and put it through those tests. We do testing too on components. So we do a lot of shock and vibration testing on components in order to make sure that they can meet the most severe requirements, even beyond consideration for earthquake. There's additional military standards that we try to be able to meet on a component level. But as a whole, when the compressor is spinning, we can depending on which compressor model, we're between 10 and 40,000 RPM, right? So the way the compressor works is that we're constantly positioning that shaft in the center. So we have sensors which are monitoring the position of the shaft 80,000 times per second, and then repositioning it to make sure that it stays in the center. If for any reason the orbit of that shaft starts to move outside of what we see as our acceptable limits, then the compressor is going to just stop. It's going to shut down, and it's going to say that it's got a bearing fault. And so that bearing fault can then be reported back to the chiller. And assuming that everything is stable again, and there's been no major incident such as what you could have with an earthquake. If everything goes back to normal, then the chiller clears the fault. The compressor can start back up as normal.
So now, obviously, the one big question is, what is the relative cost of this technology compared to other technologies that you could purchase?
Right. Yeah. So. Of course, our compressor is a premium product, and there is a higher cost associated with that. But what we focus on, and what our OEMs do a very good job of focusing on, is looking at the total payback period. And with the efficiency that our product provides and the other benefits like we talked about, we typically can see a payback versus other technology within 2 to 3 years. And, the point that Eddie had mentioned is also a really good one about our compressors having no performance degradation over time. So that's a big factor in the total cost of ownership, and something that needs to be considered, because for a well-maintained chiller with Turbocor compressors, we will be able to deliver the same energy savings year after year. So that's something that other compressor technologies cannot claim.
Now, is that something that, as far as maintaining that, would you say that would be a benefit, not having necessarily have the staff that needs to monitor the oil? Is this something that is beneficial, or is that it's an easier system to maintain from an owner standpoint?
Yeah, this is Eddie. I'll take that question. Yeah, that's very true, because it does require a significant amount of labor hours, as well as a specific skill set of service technician to do all those tasks. That I mentioned. Changing the oil, doing oil analysis, changing the oil filter. All that stuff requires time and requires a person who is knowledgeable on the use in the area of chiller maintenance. Because those tasks are gone, that's significant cost that is taken away. Plus, it also gives a lot of peace of mind to the customer, because they don't have to worry about those tasks, which, if neglected, could result in a catastrophic failure of the compressor.
Right. So they're basically focusing just on making sure that the water chemistry is right, and making sure that the actual heat exchanger shell is clean on an occasional basis. Yeah,
that is correct.
All right. Well, I really appreciate you guys being on the podcast. What's some final thoughts? What should people know?
Yeah, I think we could both provide some input on that. One thing I'd like to address that's kind of some parting thoughts here is, and Frank started to allude to that in the beginning, is that typically most customers have thought of our compressor, and I guess as kind of any compressor for that matter, as sort of air conditioning or comfort cooling types of applications. With the recent launch of our new high lift compressor, we've really starting to make inroads into applications that have normally not been thought of for use in our technology, which is electric heating. And electric heating is we see as a trend that is really taking hold. I mean, it's happening today in Europe as well as in China, and we see that issue moving. It's going to happen in North America with regards to replacing traditional fossil fueled heating, whether it's a boiler or some other heating device using natural gas or oil or some other fossil fuel type, but instead transitioning to electric heating, where your comfort cooling chiller is actually going to be providing the heating as well as the cooling. In applications today, a lot of times that heating that gets extracted from the building, a lot of cases it's just wasted. It goes into the atmosphere. But in this era of electrification and awareness of reducing the impact of global warming, we see this as an opportunity to use our technology to help reduce carbon emissions by helping to transition away from fossil fuel heating.
Now, what's just out of curiosity, the high lift? Where is that being applied?
So the high lift compressor is a compressor we actually launched last year, and the specific applications that it's optimized for is in applications just like its name, high lift, where when we say high lift, that means we're talking about the difference between your saturated discharge temperature and your saturated suction temperature. Or in other words, there's a big pressure ratio difference on your high side condenser versus your evaporator. And those types of applications are things like air-cooled chillers in hot ambient climates like the Middle East or Phoenix, Arizona, or it could be heat pumps, heat recovery, where someone wants very hot water for potable water use, ice rinks, thermal storage. Those are applications where you see that big difference in condensing pressure versus evaporator pressure. And that compressor that we launched, what we call the high lift compressor, is designed and optimized to handle that high lift application.
Yeah, that's a great point. The other point I would say that I don't think a lot of people are aware of is that, when we first created this technology several years ago, it really was focused on just a handful of compressors. And like Eddie's mentioning, we have a portfolio of compressors now with all kinds of different capabilities. And over the years since Turbocor had first started, last year we passed a big milestone in that we have more than 80,000 compressors in the field operating. So, the largest installed base of magnetic bearing compressors. And, that's one of the things. So we start to see other companies coming on board and offering oil-free options, and we really think that's fantastic because it really demonstrates that this technology has been widely accepted, and we're very proud to have been able to be the leader and the pioneer to help make that happen.
All right. Well, I appreciate both of you guys. Thanks to you, Frank and Eddie, for coming on the podcast and spending some time with us.
Thank you.
Thank you.
All right. Thanks again to Eddie and Frank for taking the time to chat with me. Check out the show notes for things that we talked about during the interview. You can find those show notes over at hvac360.com/157. And thanks so much to you for taking the time and listening. Hope this was helpful. If you know somebody who's looking to step up their HVAC game, consider sharing this episode or another one of your favorites with them. This is kind of by far really the best thing you can do to spread the word about the podcast. You can also subscribe over at hvac360.com for a weekly dose of the written word, or browse on over to my YouTube channel and subscribe if video is more of your thing. Lastly, I'd be greatly honored if you'd consider leaving me a 5-star review over at Apple Podcast. That's a wrap for this week at HVAC 360. I'm your host, Matt Nelson, helping you be the best and the brightest in the field of HVAC. And as always, know what you build and share what you know.